Hello class, today we're going to be going over lesson 3.4, and that's how to construct functions to model linear relationships. So let's start with a formula we know models a line. So if you guys remember, when we learned in chapter 2, we learned about slope-intercept form of a line. And what slope-intercept form is it's the equation y is equal to mx plus b, where m is your slope and b is your y-intercept. So remember, we've gone over at this point that m could also be called our constant rate of change. The slope and constant rate of change are two interchangeable ways to talk about m. Now, b, or the y-intercept, can also be called the initial value. Or when you start your problem, that's what you're initially starting with. So we now have an equation y is equal to mx plus b. All right, so what we're going to do today is we're going to model lines and we're going to model formulas for functions, because at this point we should all know that any line on a graph will give us a function. And we're going to talk about how we can model them using this equation. So I think it'd be a good idea for all of you guys to get this down, even if you already have it in your notes. All right, so how do we write in slope-intercept form if you can't find the y-intercept? So right here, it tells us 10 toys cost us $30 and 5 toys cost us $17.50. Now it tells us the first thing we want to do is determine the constant rate of change. So what we do in this problem is we do 30 minus 17.5 divided by 10 minus 5 is equal to, eventually we get 2.5. Now you might be asking yourselves, well, where did we get this equation right here? 30 minus 17.5 over 10 minus 5? Well, that looks kind of confusing. Remember, this is our equation to find our constant rate of change, right? Or our m. So what this actually comes from is our formula for slope. y2 minus y1 over x2 minus x1. So in this problem, the toys were my x values and the costs were my y values. So we did 30 minus 17.5 divided by 10 minus 5, or y2 minus y1 over x2 minus x1. Now what we can do here is we can use the slope and one of the set of x and y values to plug into our equation and then eventually to solve for the y-intercept. So here, since our slope is 2.5, we replaced our m with 2.5. We set one of my y values to be 30 and one of my x values to be 10. It's important here that you use the same set here. We can't, for example, use 30 and 5 or 10 and 17.5. We have to use one set of x and y coordinates. All right, so now I plug in for y, I plug in 30, and for x, I plug in 10. And I get 30 is equal to 2.5 times 10 plus b. Now I just have to do some algebra here and solve for b. So I get 2.5 times 10 is 25, and then 30 minus 25 is 5. So that means my initial value, or my y-intercept, is 5. Now we have all of the information we need to plug this into slope-intercept form. So remember, our m is our initial value, so I replaced in the equation y is equal to mx plus b. We replaced m with 2.5. B is my initial value, or the y-intercept, so I replaced b with 5. What we found was equal to b. And I get the equation y is equal to 2.5x plus 5. All right, let's try some of these on our own. Write the points to create the equation of the line. 1, 2, and 5, 6. So again, this is to fill in our equation. Y is equal to mx plus b. Y is equal to mx plus b. All right, so the first thing we want to do here is find our slope, or find m. So since we don't have any graph here, we have to plug it into our equation here. y2 minus y1 over x2 minus x1. So back up in this, remember guys, it doesn't matter which one you choose to be y2 or which one you choose to be y1. It just matters that they come from the same pair. So since this one comes first, let's call this x1, y1, and this one comes second. Let's call it x2, y2. That means 1 is my x1, 2 is my y1, 5 is my x2, and 6 is my y2. So here I need to do 6 minus 2 over 5 minus 1. 6 minus 2 over 5 minus 1. y2 minus y1 over x2 minus x1. 6 minus 2 is 4. 5 minus 1 is also 4. So I get 4 over 4, which is equal to 1. All right, so now I can go back to my equation here. Y is equal to mx plus b, and I can replace my m with 1. So we get y is equal to 1x plus b. But notice this is in slope-intercept form here, right? I still have to solve for my b. So what I'm going to do is I'm going to replace my x and y values with my x and y values from up here. So I'm going to use the coordinates 1, 2. So since my y is 2, I'm going to replace the y with a 2. Since my x is 1, I'm going to replace the x with 1. Now the reason we're doing this is I now have an equation with only one variable. So whenever we have an equation with only one variable, we can use algebra to solve for that variable. What we have to do here is we simply have to multiply and distribute. 1 times 1 is 1. So I get 2 is equal to 1 plus b. And then we use some opposite operations. The opposite of a positive 1 is a negative 1. So I'll subtract 1 from both sides, and I will get 1 is equal to b. Now that I know what b is, I can go back to my original equation here and substitute in my values. So I already found out that m is equal to 1, so I'll change my m with a 1. We just now found out that b is also equal to 1, so I'll go back to my equation and exchange b was equal to 1. So my equation is y is equal to 1x plus 1. Y is equal to 1x plus 1. All right, so that was one question for us there. Again, break it down what we did. First, we found our slope by using the formula y2 minus y1 over x2 minus x1. After we found our slope, we plugged that in as well as a pair of coordinates. For example, we used 1, 2. I plugged in 1 for my x value, 2 for my y value, and then I solved for b. Once I knew that b was equal to 1, well, then I had the two things I need to write slope-intercept form, which is slope and the y-intercept. So we simply replace them in our original equation. All right, let's do another problem here. What is the equation of a line that passes through the point 4.2, comma, negative 4.25 with y-intercept 2.5? So again, we're writing using the slope-intercept form on this, or y is equal to mx plus b. Y is equal to mx plus b. So notice I don't have my slope on this, but I do have my y-intercept. So I can go to my equation here and replace my b with the number it gives us, which is y-intercept is 2.5. But I still don't know my slope, or my m. All right, but we do have a pair of points, so I can plug those in for my y and my x values. So here, my y value is negative 4.25 right here. So I'm going to replace the y with negative 4.25. My x value is 4.5, so I'm going to replace my x with 4.5. So I get negative 4.25 is equal to m times 4.5 plus 2.5. All right, first thing we need to do is our opposite operations. The opposite of adding 2.5 is subtracting 2.5. So I'll subtract 2.5 from both sides. Negative 4.25 minus 2.5 will give me a negative 6.75 is equal to m times 4.5. All right, the opposite of multiplying, the opposite of multiplying by 4.5 is dividing by 4.5. So I'll divide by 4.5 on both sides to cancel out the term touching my m. Whatever you do on one side, you also have to do on the other. And 6.75 divided by 4.5 will give me the number 1.5, or negative 1.5 rather. So that means that m is equal to negative 1.5. All right, so now I know my m and I know my b, which means I have all the all the numbers I need to write my slope-intercept form. All right, so since m is equal to negative 1.5, I'm going to come up to my slope-intercept form and I'm going to replace m with negative 1.5. Since b is 2.5, my y-intercept is 2.5, I'm going to come back and replace my b with 2.5. And now I get the equation. Y is equal to negative 1.5x plus 2.5. All right, we have about one or two more problems here. So a car moving at a constant speed passes a timing device at t is equal to 0. After 8 seconds, the car has traveled 840 feet. Write an equation of this in slope slope-intercept form. All right, so notice when it says t is equal to 0, if this was on a graph right here, that means my graph would look something like this. Now, where have you seen a graph looking like that before? Well, it's proportional, right? So if a graph is proportional, that means my y-intercept is 0, meaning when I write the equation y is equal to mx plus b, I can replace this plus b with 0. And it also means that I could find my slope m by doing y divided by x. So again, let's just write out our equation here. We're using the slope-intercept form, y is equal to mx plus b. Alrighty, so in this problem here, let's start by finding my m. So my m I can be found by doing y divided by x. So here I have 8 seconds. A car has traveled 840 feet. So it's up to you to decide what your x is and what your y is. The way I like to think about this is, remember when we did unit rates last year? If you remember thinking about what a unit rate is, it's things like miles per hour, feet per second, dollars or price per pound, things like that. Remember, it's the cost we're related to what. So on this question, it begs sense to ask yourselves, do you think I should be writing feet per second, as in how many feet you travel in 1 second, or seconds per feet, how many seconds it takes you to travel 1 foot? Hopefully we all know that feet or seconds per feet doesn't make much sense here. We normally work with feet per second, so that's what we want to find here. Our feet per second, or my 840 feet divided by 8 seconds. So feet per second means feet divided by seconds. Here I'll do 840 divided by 8. 840 divided by 8 is equal to 105. So that's my m here, 105. Now we just got to write the rest of our equation here. Y is equal to 105, or m times x plus b. But what was my plus b, everybody? It says t is equal to 0, so we get 0 for b, which means the equation is y is equal to 105x. Simple as that. Y is equal to 105x. So here we were able to do this nifty little trick because it tells us the timing device is at t is equal to 0, or basically my graph is proportional. So knowing that, I could find my slope by simply doing y divided by x. And we get that because it's a derivative, or we created it from our original slope form. But since we're just subtracting 0, 0, we could just do it as y over x. So here we do 840 divided by 8, which is equal to 105. All right, last question for us here. Create an equation from the graph. All right, this is something we have done standard at this point. This is just using a graph here. Y is equal to mx plus b, mx plus b. So let's start by finding my y-intercept, since that's the hardest thing I could possibly do. Remember, the y-intercept is where my graph crosses the y-axis, which is right here at the point -5. So I'm going to replace my b with -5. So I still have y is equal to mx plus -5, or y is equal to mx minus 5. To find my slope, I could find that by doing the rise over run. So here I go up 1, 2, 3. So my rise is 3, and my run is 1, 2, 3, 4. My run is 4. So that means I get the equation y is equal to 3/4 x minus 5. Alrighty, everybody. At this point in time, I need you guys to create a conclusion using 2 complete sentences about what you learned today. As a reminder, what we talked about was finding a way to model a function, a linear function, using an equation. The equation we used was y is equal to mx plus b. So what's going to happen in these problems is you're either going to give 2 points, or you might be given the y-intercept in 1 point, and then you'll have to solve using algebra for the piece you're missing. All right, everybody, hope this helped you out today. I will see you all in class tomorrow. If you have any questions, please bring them. Have a great rest of your day, everybody. Peace out.